Welcome to part 4 of the DMX for Unreal Engine virtual production mini course, which is the last installment for the initial set of tutorials and the minimum of what you need to get up and running with DMX and Unreal. Part 4 builds on the project created during part 3, or you can reference the completed sample project on GitHub in the description. In this section, we will be setting up to output to physical lights through custom code as described in the overview video. It is also possible to integrate with the built-in DMX library features, however this solution is what came easiest to me and should get you up and running on mapping virtual lights to physical lights, and is perhaps the route you'd want to go in general in dealing with custom DMX output and mapping code. So, without further ado, let's jump back to our project from last time, and right-click to create a new folder called Blueprints. And then let's go into that folder and create a new blueprint class, which is of type actor. And we're going to call it BP_DMX manager. And then we're going to open that up. And then we are going to go up to the Add Component section and click that. And then we're just going to search for it. We are going to add a DMX component, and calling it DMX is fine. Just for the sake of completeness, we can specify our sample DMX library here just to make sure it has a DMX controller. That may be redundant, but it's a good practice anyway. So then let's compile and save our asset real quick. And then let's go to the class defaults. And for some stuff we're going to be doing in a little bit later, we're going to set auto receive input to player 0. Okay, and then we are going to create a new variable by clicking the plus icon here, called channel value map. And that should be in camel case without spaces. We'll set it to public, and then we will change the type first from a single variable to a map. And actually it doesn't like that it's a Boolean, so we need to change that first. So we'll change the base type to integer, and then we'll change that to a map. And then the first type is an integer, and then the second type is a byte. Then compile. So we will need to initialize the channel value map to have all 512 channels in it by default if we want to output ArtNet for that to really work really properly. So to do that, we are going to head over to the construction script. This is a special script that runs every time a property changes in the main editor window. This could be movement, it could really be any property whatsoever a script is going to run. So this is just temporary, but it will let us auto-generate some useful properties that we can then stick in the default value here. So we will grab our new channel value map with a get, and then just drag off of the little icon here, and it'll give us the right-click menu. That's more context-sensitive, or if you're not finding what you need, you can untick that and do a broader search. Here, we're just going to do a clear of type utilities map and then clear. And then I'm not going to hook this part up until the end, or else it'll run probably while we're going. We're just going to right-click and type for loop, and we just want a regular flow control and then for loop. And this is going to be index 1 to, very predictably, 512. We'll link the execute pins, and then off of our channel map variable, we are going to do a utilities map add. And then we are going to link the key of the map to the index. We're just using numbers for the keys, so that makes it easy. And then the default value of 0, we just want to initialize it with 512 blank entries. So we iterate through that. So we'll clear it and then add 512 entries and it will do the thing. Compile and save. And then we go over to the editor. We haven't dragged one into our level yet, so let's do that. And when we do so, you'll see we have 512 elements already, even though we have not set the default properties. So that's this script running. So we can come over here, right-click on all of that to copy it, come back to our construction script, break the link to the for loop, compile it, and it will clear that out because it's calling a clear every time a property changes. And then we can break that link too. And then we can come back to our channel value map, default value, right click and paste. And we have 512 addresses that are initialized to 0. So now we can compile and save that. And then once again, rather than, so right now it still has 0 because it's not triggered by a construction script, but now we can click this arrow to reset it to the default values, which is populated. Or we do that with our construction script disabled. If we bring in a new one after deleting the old one, it will be initialized with the default value of a full universe of blank channels. Like so. So, with that in place, we can move over to the event graph where the main logic happens. Next, we can create a variable b show update. And this will just give us a convenient way to basically toggle the input on or off, whether or not it's actually running or not. So create the new variable. We make it public by clicking the little eye icon to make it show up over here in the editor panel. And then we change the type to a single variable of the variable type Boolean. And then we compile, and we can just say, because we set it to listen to player 0, we can grab a enter key event on the enter key. We can flip-flop between two code paths. One where we set it false, and then a second where we set it true, and we can default it to true. And then for the sake of documentation, we can call a print string on the beginning of the game that says press enter to toggle ArtNet output. And then here we can just say ArtNet disabled. Control C and Control V to paste. And then we compile and save. All right, and then we can quickly go over to our game and run it. And then we've got our little message, enter to toggle ArtNet output. And then if we do that, we get the message. Now it's not actually doing anything yet, so that's next. So on event tick is an event that fires once on every frame and should be used fairly carefully. In this case, rather than, well, because sending DMX basically sends an entire universe at once, it's basically one big data packet with all 512 addresses. You basically want to do it from one central place once per frame, no more and no less. So our DMX manager where we have one of those and then multiple of other blueprints that send it information of what to do is sort of a good setup of doing that. When you have multiple of those, like if you just made a light blueprint and we're sending DMX in there, as soon as you made two of them, it would be glitchy in terms of, if you have a light that just has its own DMX data and the rest are zeros, and then you have another one that's at a different address with different DMX data and the rest are zeros, those two are gonna be competing and flickering, and it's most likely gonna end up in an engine crash, which I've noticed in testing, which, to be fair, is somewhat expected. So yeah, don't do that. Just do it this way and it'll work well. So let's grab our v should update variable, which is already set up to be toggleable. And then let's do a branch off of that. And then link that up. And then, as long as that's enabled, we will go ahead and send context sensitivity is screwing me up there a little bit, but so I uncheck that. Send DMX, yep. Or actually, no. This is the other one. So this can integrate more with your DMX library assets. I haven't experimented too much with that one yet. Yeah, so that's where you map the names of things to integers. So I guess that's not too terrible, but so far I was just using the send DMX raw, just because I'm more familiar with DMX and that made more logical sense to me to start out. I'm sure we can iterate and do some interesting things with the send DMX regular one as well. But for now, we'll do a send DMX raw, where it's just a integer ID and a value. So in this case, send DMX raw, artnet. Yep, and then so the target, we want to grab a DMX subsystem, which is basically doing all the stuff under the hood as far as the getting the DMX stuff to work. So then we have a universe index. For my purposes, I was having .2 input with these lights on the first universe, index 0. So in this case, the way I had it set it up was having the output on a second universe, and I set the ArtNet node to the second universe, in this case, universe ID 1. And then here we have our channel value map, which we've initialized with a full universe, and we just plug that in right there. Then on every frame, it will just update that with the latest DMX data. And if you wanted to expand this out to multiple universes, conceivably you can do that. You just need multiple of these guys with different universe indexes. And if you have stuff that listens on ACN, you can do that too, but you might have to tweak some other things. Since the sample fixtures mainly run on ArtNet, I'm just sticking to ArtNet. That was the main bit here. And then next we want to right click. We want to add custom events. And so we will call it assign DMX channels. And then we are going to add to that two things. We can add input variables to this. So we can add a variable I start address, and we can make that a integer, just a single one, and then we can make another variable DMX params, as in parameters, and we will make that a map. The first type is integer, the second type is byte, just like before. And then from there, we can do a number of things. First of all, we are going to grab a for loop, just a regular one. And then we're not going to do 1 to 512. We're going to do it a little bit differently. This will basically make it so we can have lights call this event externally and basically tell our DMX manager just about the parameters that they're using, and then update those in the main DMX variable. So here we can drag off of here and add a get the length of it, basically how many entries it has. And then we can drag off of this, grab a subtract. We want to subtract 1 off the length to get the last index of it. And then we want to add that, integer plus integer. Hold Alt to break a connection. Hold Alt and click rather. So we want to add this with the start address so that the first index is the start address. And the last index is this number we've just calculated here based on the start address and the length. And then from there, grab a subtract from the for loop index and plug that in with the start address as well, and actually to stay organized, I'm just going to double click on this line to make a reroute node, which then we can branch off of. And then we can create a reroute node another way by searching for it. And then we can use that to run there so we can clean up our blueprint wiring to make it a little more neat. Then we can grab, let's see, off of, yeah, so to that point, I'm going to add some more of those so I can route this more cleanly from our DMX parameters input to our output here, where we're going to do a find. We're going to plug the index into the index minus the start address. And then from there, we are going to grab our master channel value variable somewhere relatively neat. And then we're going to do a add, which will either add a value if it's not in there or update it if it is already in there. So we'll hook up the execute into that. Then the key will be index. And the value will be where we get the appropriate number from our input parameter, which is a limited subset for the parameters that just a light is using, or any other DMX thing that you're doing. So for the sake of example, I am just going to add a print here, just so we can see it when we do call it in a moment. We'll probably remove this before we're done, but for the sake of demonstrating what we're doing here, I will include that for the moment. So compile and save. And then I believe this part is actually done. This is pretty much all we need to do. So we have pertinent output, which we can toggle, and we sort of explain what's going on when we run it. And then we set up a way of updating DMX parameters externally from things that we actually want to do custom logic with. So Control-Shift-A to save all. Okay, so now we make the second blueprint. Let's right-click in our content browser in our blueprint folder, create a new blueprint class of type actor. I'm going to call it BP Fake Sky Panel is what I called it. So then we are going to do a couple things. We are going to, like before, scroll down to class defaults. If it's not already selected, go ahead and click it up here and scroll down to input, auto receive input, layer 0. Then we are going to add component. We're going to add a scene component just so we can have an offset, because this is what we're going to rotate. I'll elaborate more in a sec. Then we're going to add 2 more components to it with it selected. We're going to add a rect light, and the default name is fine. We're going to set the Y rotation to a specific number, in this case 270, so it points at the ground. And then we are also, with the scene component selected, we are also going to add an arrow component just so we can see better what it's doing. And that will also be 270 degrees on the y-axis so that it points downward. Compile and save. Then see, we're going to want to have a few variables. We're going to first want to create a new variable for DMX manager reference. We'll make it public so we can see it in the main window. We will have the type be our BP DMX manager, and we will get a object reference. We will add another integer and byte map for our DMX output for our specific light. So I'll call it DMX output. Make it public just because so we can see what's going on. Not necessarily recommended for, production code that you're going to ship to customers, but for iteration purposes, it's a nice thing to do. So then we set the type to a integer. We set the variable container to be a map. Secondary type of byte, like before. Compile and save. We don't actually need to do anything here in terms of changing the defaults in this case. And then we will make another variable. This is the last one, I believe. Start address. And instead of a map, we're just going to make it an array. So this will allow us to have multiple start addresses if we want to map the same virtual light to multiple physical lights if we like, which I'm going to go ahead and do in this case. And in this case, I've patched the physical lights on Universe 1, which we're already outputting to with the DMX manager, and then they're on channel 174 and 180. I'm using RGB components on the output, so if you just have a simple 3-channel Parcan, you put them in like 3 or 4 channel mode or something with RGB first, and you address them at 174 and 180, and you set your ARNet node to also be on Universe 1. And by that I mean the second universe. Check the manual for your specific ARNet node. Then this code should actually work on those as well, at least in terms of the first 3 color values updating, which you would be able to change or write some additional code to change or tweak the existing code. But, this is made for tilt buttons, so if it doesn't have tilt, it's not going to be completely relevant, but this should give you some ideas of what you can do to do your own stuff with those in place. Okay, so we're going to want to go to the event graph and do a couple of different things. On the event begin play, we're going to want to get all actors of class. I can type get all actors of class, and then we want our BP DMX manager class, and then we want to grab a isValidIndex. So with the default value of 0. Basically, when the game starts, it will grab all of the actors in the scene of our specified type, and then output a list of them. So we check if the first one is, if there's anything in there, and then if there is, we'll do a branch. If there is, we will grab our DMX Manager reference and set it. We're going to get that reference and then set our DMX Manager reference on the game start. And then I'll clean this up a little bit, double clicking to add reroute nodes. And then if we want to, we can just say, we can give ourselves a little reminder. Couldn't find DMX Manager. So if we make a new map and drop one of these guys in without dropping a DMX Manager in, it will tell us, hey, I couldn't find the DMX Manager. And then this is really, the next part is kind of the meat of where we actually start doing some interesting stuff with this. So we will grab 2 keyboard events. We will grab the down key and the up key. We will also want to grab our scene component, a reference to that. And then we will want to get relative rotation. And then here's a fun trick if you weren't already aware. Vectors and things that have multiple components in them, you can right-click on it and split the struct pin to get the components without using another node. Handy little trick there. So if we drag off of the roll, I tried it with pitch first and that was behaving a little funny. It works properly with roll. We're going to drag off of the roll and grab a float is greater than float. And we can add a reroute to clean that up. And then in here, we'll put, in the case with the pixems, they have, the range is plus or minus 122.5 degrees. So since we're going to be incrementing it by sets of 10, negative 119 degrees is the number we want for the logic to work here. So negative 119 degrees. If the roll is bigger than 119 degrees, we will grab our scene component and add another reroute node. So if we're bigger than 119 degrees, throw in a branch. And then in the event that branch is true, we add relative rotation. And in this case, we set it to be negative 10. There's some other parameters here you can mess with, but we don't need to worry about them. So when the down key is pressed, if we're over negative 119 degrees, which is to say we're closer to 0, then go ahead and subtract another 10 rotation. We're going to basically do the reverse for the other side with a float is less than float with positive 119. And then true, we will add relative rotation again. This time it will be positive 10. So again, if we're essentially closer to 0 than 119 degrees, we'll go ahead and add 10 to the X rotation. Likewise, we will get relative rotation again of the same scene component. Split the struct pin again, just so we can get at it easier over here. I will add a reroute node so I can kind of merge these code paths. And then we're going to grab our DMX output variable because we're going to start doing stuff with that. We're going to have a add here, and we're going to have a string of these adds in a line. So we'll hook that up, and then we'll add more in a second. Then we grab off of our X rotation of the scene component. In this case, we are going to map range clamped. So this will let us map the in-game rotation to, and the rotation capabilities of the fixture to the DMX values of 0 to 255. So this is just going to do a little bit of math for us to normalize it, that we don't have to worry about actually coding the math of it. So negative 122.5 by 122.5, outrange 0 to 255, and then this is a float, which is sort of a decimal variable type. So we are going to want to truncate that to an integer. We'll move this guy up here. Actually move this back a bit. Actually, yeah. So since we're going to add several more of these guys, just drag off. I've noticed that the map add nodes are a little bit funky if you try to just copy and paste them, so I drag off of the actual variable each time. However, we can add a reroute node. And then actually we can add a reroute node a little ways out. Let's see, we want 1, 2, 3, 4, 5 add nodes. We can just double click and then drag off and add. And repeat that a few more times. One, two, three, four, 5. And then can just clicking and dragging will box select. You can hold shift down to multi-select. And then you can sort of clean up the spacing a little bit. Okay, so we're doing red, green, blue, dimmer, and then tilt. And we're not doing anything with tilt speed, and because we're specifying the start address, we don't need to set anything. It's already initialized to 0 for us. The 0 tilt speed is basically the fastest speed, so we don't need to do anything there. We just want it to quickly jump to the position rather than gradually fading. Although I suppose you could do that if you wanted to. You would just add an extra one for at the end here. So, and also because we're doing relative output and we're doing some math on the other end, we can just number these 0, 1, 2, 3, and 4. So these are DMX addresses in the context of the fixture, essentially offsetting from the start address, which we have already set. So just linking the last of these guys up. So this one is, so the first 4 are going to be values of 255. So that this will be white at full brightness. Granted, as an RGB fixture, the color rendering index is not going to be amazing, but for demonstration purposes, it's fine. To be clear, I really would not recommend the PixEms for film or broadcast applications or RGB-only fixtures in general for their extremely poor color rendering performance, and are not designed for such applications. Live events applications tend to use either white LEDs or traditional arc lamps for stage wash, and illuminating performers with broad spectrums of light. And the limited spectrum coverage of RGB-only fixtures is utilized only for effects lighting. You want to have a tilt batten with at least RGBW coverage. You should look into the, granted much more expensive, GLP X4 bar 20 or X4 bar 10. For virtual production, RGBW fixtures are probably the minimum of what you'll want if you're going to branch into stage lighting side of the DMX lights industry. However, proper film lights are certainly preferable as they are purpose-built for high color rendering indexes. To be very clear on this point, I will also link an additional video in the description that goes into much greater detail on why RGB-only fixtures have such poor color rendering. And then our last one, number 4, is where we point our truncate to, and then it'll do a conversion in line to our byte format. And then once we're on our last add, we can grab our array of start addresses. And then in this case, we actually do want a for each. So however many we have, it'll call it however many times. Then we can select this guy and mouse to just the edge of it, and we can move that guy around. So in this case, we want to grab our DMX Manager reference, a get, and then here is where we can call our assign DMX channels. So we pass in the element of the array as the start address, which here we've set our start addresses already. Or when you drop this into the editor, you can also, of course, override these, but by default, it will be what we've already set. So then we pass in our element for each, and then we pass in our DMX parameters. So these will be the same. You could also do custom logic to sort of break these out, but I feel like realistically you'll probably have one physical fixture per virtual fixture, so then you just add one starting address, and looping through an array of 1 is still the same functionality, but it lets you add more very easily. So yeah, then we plug in the execute pin for loop body, and then, oh yeah, so in this case, I dragged this out here, so I actually can do this like so instead. Okay. So yeah, that should be everything. So we can do file, save all, and then and hit play. And actually, okay, so now is where we need to actually bring some of these in. So we can grab our player start and drag it back a bit. And then we can actually drag in our big sky panel. We need to go back into our sky panel and have the arrow not hidden in game, so we can see it better. Arrow components default to being hidden. Okay, and you can see our variable getting called, and at a certain point it won't let us go any further, which maps to the physical range of the actual lights. So then we can grab our sample DMX library, I believe, and drag off another window here. And then I believe we set that to universe 1. We can see on 174 through 175 those values. If we drag the monitor tab off into a window, it goes away when we move to a different tab. But if we drag the whole thing off, it will stay. So now we will be able to see the DMX values changing on the output, which tells us our code is working correctly. And you can see there is a space of one channel for the rotation speed being at the default 0. So you can add a map add at 179 if you want to control that value. So now that we can actually see our code working with the actual ArtNet output, now we can do a quick cutaway to showing them working with the actual lights. So this should conclude part 4 of the DMX for virtual production mini course. I plan to make some other videos beyond this in terms of tutorials and things. However, this concludes the first section of those videos for the initial batch. So definitely provide feedback if you're interested on anything you had problems with and other tutorials that you'd like to see. I'm definitely interested in putting together a little bit more in-depth tutorial on .2 and how I actually made the sample show file, and possibly going into some other things, but that should do it for the initial round of tutorials. So thanks for watching, and hope this is able to get you up to speed with DMX with Unreal. So thanks for watching. Have a nice day.